So guys, are you able to hear? Guys?
Yes, sir.
Okay. So let me share my screen. Just a moment. Okay. So hope you remember what we were seeing, right? So we were seeing enthalpies of formation, right? Enthalpies of combustion, and we were able to connect this enthalpies of formation, enthalpies of combustion with the overall enthalpy of a reaction, right? So if you can look at it, I think 1 second I can show you what and all we saw. Right. So this is not what I want to show. Yeah, no, not this. Okay, so if you can remember this, right? So I told you the enthalpy, overall enthalpy of a reaction, right? 1 second, people. Right. So the yeah, what is wrong? Yeah. So the overall enthalpy of a reaction, you can see, right? I told you the overall enthalpy of reaction is going to be like this, right? So you can see that the overall enthalpy of reaction can be expressed in terms either in terms of enthalpies of formation, that would be total enthalpy of formation of products minus total enthalpy of formation of reactants. And if it is going to be in terms of enthalpies of combustion, it will be in terms of enthalpies of combustion of reactants minus products, right? That's how it is, isn't it, people? Right. So we will continue with the other types of enthalpies, or we'll do one more problem so that you'll be able to catch up with this. Right. So give me a moment. Just give me a moment, people. What? Okay, I think not able to find these things. So, anyways, people, we can go on with the next. What is that? Next enthalpy. We'll do the problems later. Okay, fine. So the next enthalpy which we are going to see is going to be, right, is going to be bond enthalpy. Why is it happening like this? Really something wrong. really wrong. Phew. Guys, I think I have to. Why is it happening like? Just guys, I'll log out. I think I will just come back 1 second. Oh God, this is so irritating. Guys, I'm really sorry. Like it's something. There's a problem here. Guys, I'll leave. I'll join again. Just give me a moment. Abhishek, I'm making me the host. When I come back, please make me the host. Is it okay?
Sir. Okay, sir.
Okay, so yeah, back to the previous one. So there's a problem, people. I don't know. I'll just recover it. So today we'll manage with the board, right? Okay, so we were seeing. Oh, wait, 1 second. Okay, so hope this is good. Okay, we'll right away start it. It's already time. Okay, so as I told you, right? So we were seeing enthalpies of formation, enthalpies of combustion, and we connected them with what is that? Overall enthalpy of a reaction, isn't it? Right. So we had to do some problems, but right now, okay. So if they give you this equation, people, right? So they have given COCl2 plus H2S gives 2HCl plus COS, and they have given delta H to be minus 79 kilojoules. And there is one more equation, COS plus H2S gives H2O plus CH2, and the delta H for this reaction is 3.42 kilojoules, right? And they're asking for this reaction. Okay, for this reaction, what is the enthalpy value? That's what they're asking. Okay, so hope you're able to see everything, right? So they have given you two equations, right? And they're asking you to find the enthalpy for the third equation, right? So we all know how to do it, right? We have to do addition, subtraction, multiplication, whatever you're going to do, right? And but you have to make sure that that is getting reflected in the what is that, in the enthalpy values also, right? So quickly we'll do it, right? So as I told you the tricks, just this is my required equation, correct? This is my required equation. So in the required equation, see where are all the reactants and products, right? So first off, for example, say I take COCl2, right? I take COCl2. In the required equation, COCl2 is in the reactant side, correct? And I have to check where is COCl2 in the given equation. So I see that COCl2 is here in the reactant side, and there is 1 mole required, and yes, there is 1 mole required. Okay, so you don't have to do anything to this equation. No issues. Okay, next. I have H2S in the reactant side, right? I have H2S in the reactant side, and I have to see where is H2S. H2S is here, both here. I mean, first equation as well as the second equation, correct? And obviously now I require 2, so obviously when I add them both, I'll be getting 2 H2S, isn't it? That's it. All the other things are going to come together. You don't have to worry about it. Okay, so what do you have to do for this? You just have to add these two equations. Very, very simple. Okay, you just have to add these two equations. So that's why if you add these two equations, you'll be ending up with this equation. So obviously the enthalpy value would be minus 79 plus 3.4 would have been the answer. Everybody understood, guys?
Yes, sir.
Understood.
Okay. So like this, I told you there can be 3 types of problems. First type of problem would be they might ask you to find the difference between enthalpy and the internal energy. And the second type of problems can be, say they give you the enthalpies of formation or enthalpies of combustion, and they'll give you a reaction, right? And they ask you to find the overall enthalpy of the reaction, right? And the third case of problem is like this. They'll give you multiple equations, and along with their enthalpies, and they'll give you a new equation, and they will ask you to find what is the enthalpy for the given equation. These are the types of problems. Now we are seeing only two types of enthalpies, so the problems might not be that complicated, but we are going to see more and more enthalpies, right? All those enthalpies can be given to you. Okay, fine. So we'll move on, people. We'll move on to the next type of enthalpy. Okay, if you're taking this down, just wait for one more minute. A lot of time got wasted today. I don't know what is wrong.
Done, sir.
Yeah, good. Okay, so the next type of enthalpy is what is called as bond enthalpy, right? Or it is also called as enthalpy of atomization. Okay, enthalpy of atomization, or it is also called as bond enthalpy. So you will be representing bond enthalpy with B, or you can even represent it as delta H ATM. That means enthalpy of atomization. Both are same. Okay, so first take down the definition, people. I'll give you the definition now. Please take it. Okay, it is the enthalpy change occurring. It is the enthalpy change occurring when 1 mole of a compound, is converted, when 1 mole of a compound is converted into its elements, in gaseous atomic phase, into the elements in gaseous atomic phase. Okay, I'll repeat the statement, right? It is the enthalpy change occurring when 1 mole of, oh wait, did I say just compound? No, it should be the enthalpy change occurring when 1 mole of gaseous compound, please make a note of it, it's just not the compound, right? It is the enthalpy change occurring when 1 mole of a gaseous compound gets converted into its elements in gaseous atomic phase. As simple as that. Okay, so from this, what you're understanding? You're understanding that I have a compound in gaseous phase. Okay, now I'm going to supply some energy. I'm going to supply the enthalpy. Right now, that entire compound is going to get converted into elements, right? But those elements are not in free states. It's not like bond, but it's not like enthalpies of formation. Enthalpies of formation, I'm going to form the compound from the elements in their standard states, right? But here, standard state or not doesn't matter, right? So what I'm telling you is, I have 1 mole of a gaseous compound. I supply some energy. Those compounds are going to get converted into atoms. As simple as that. Okay. So obviously, further, what you have to do, say for example, if I have CO2, I have to break the CO bonds. That's why we are going to call it as bond enthalpies also. And you can understand why it is going to be called as enthalpies of atomization, right? So I'll give you an example. For example, I have a bond enthalpy of say CH3OH is some X. If they give you this information, how will you write the chemical equation? That's the question, right? Fine. So you have to first of all make sure there is only 1 mole of this compound. So this is the compound is undergoing atomization, right? So I have CH3OH in gaseous phase. It should be in gaseous phase. No other go. Okay. Whatever the compound you have, you should start only with the gaseous phase because that is how it is defined. Hope you understand, right? Okay. So what I was telling, yes. So CH3OH in gaseous phase. So now it is going to get converted into atoms. So what are the elements present? Carbon, hydrogen, oxygen, right? So I have one carbon atom. So carbon atom in see, when I see, it's not graphite, it's gaseous phase. That's what I'm writing here. Okay, carbon atom in gaseous phase, right? Plus, what is there? Hydrogen atoms, right? Hydrogen is there, and there is 3 plus 1, 4 hydrogens, right? 4 H. I don't write H2. Again, it's not. It's because I'm not interested in the standard states. I'm just interested in the atomized state. Okay, so 4H, right? Plus, well, how many oxygen atoms? There is one oxygen atom. Again, I'm not writing O2. Say I'm just writing O. Okay, O in gaseous. Okay, and obviously the enthalpy change for this would be, what is it? It is going to be X. That's what is given by this information. Okay, everybody understood what is bond enthalpy? I just have 1 mole of the compound in gaseous phase. I am going to convert them into atoms. Please keep it in mind. It is not about the standard states. Say, if at all it's about the standard states, it's exactly the opposite of enthalpies of formation. No, it is not. In enthalpies of formation, two differences are there. Right. The first difference is I don't have to have the compound every time in gaseous phase. That is one difference. Second difference is there the elements are getting formed in, the elements are there in the standard states. Here, nothing, only the atomized states and in gaseous form. As simple as that, right? So I'll give you one more example. So now you're going to tell me. So if I have bond enthalpy of, say, what should I give? C6H6. Oh, this will be very, very easy, but it's okay, fine. C6H6 is some Y. Let me ask you, let me ask someone. Who should I ask? Maybe Divya. Are you there, Kanna?
Yes, sir.
Yeah. Can you tell me how to write the equation for this bond enthalpy of C6H6? Yes. Are you thinking?
So are we supposed to break the compounds?
Yes. Just look at this, what we did
Right.
here. Yeah, look at the first example, what we did here. And this example should be a little more easier if you look at this.
B plus.
Sorry?
BE plus.
BE plus. No. What I'm asking is how do you write the thermochemical equation if I give you this information? If this information is given to you, how will you write the thermochemical equation? That's what I'm asking. Okay, so take your time. Let me ask someone else. No issues. Let me ask maybe Pranav. Are you there, Pranav?
Yeah, yes, sir.
Can you tell me how to write the equation?
Yes, sir. Sir, but I have a doubt in this also, sir. I guess it
Yeah.
may be like 60 plus 6H, but what I thought was like, will it be coming like H2 so that we could write it as 3H2?
Sorry, come again.
What I thought was like hydrogen may be considered like 2 atoms of H2. So if you put 3 means it will be like balance, like we'll be getting 6 atoms.
No, that's what I'm telling you. It's not. It is not about the standard state. I know hydrogen exists in H2. I know that. But here it is enthalpies of atomization. Whatever is there, just convert it into atoms. As simple as that. You don't have to go for any molecular forms.
60 plus 6H.
Okay. So tell me the proper equation.
C6H6.
Okay. Any phase? C6H6 in what phase?
I guess no, sir. I'm not sure.
Look at the previous equation. What phase is this then?
So once again, sir, my headphone got disconnected. Sir, can you come again?
What I'm asking is C6H6 is okay. What is the phase of this? Solids, liquid, gases, which phase?
Yeah, that's what I'm not sure, sir.
Look at the previous equation. What is there?
Yeah, gas is there.
Okay, good. Fine. So it's a gaseous phase. Then gives
6C,
again what phase?
gas,
Good. Plus then
plus 6H.
good. Right. 6H again gas.
Yes.
Right. Then
Yes,
is it completed? Anything else is remaining?
it's completed, I guess, sir.
It's a thermochemical equation, right? What else should I write?
I ain't sure.
What did I write here? Extra. First,
Delta H is equal to X.
delta H is equal to Y. Here it is given as Y. Yeah.
Yeah.
Good. Fine. Good. So delta H for this reaction will be Y. Okay. Right. So yes, I think everybody understood. Thank you, Pranav. Right. So I think everybody understood, right? How do you write the thermochemical equation for bond enthalpies or enthalpies of atomization? Yes, very simple, right? Okay. Now there is one more type of enthalpy related to this bond breaking and stuff, right? So that we'll try to do, and then I'll be able to connect that particular enthalpy with this bond enthalpy. We'll try to do that. Okay. So the next enthalpy is bond dissociation enthalpy. Okay. Now the name might look similar, right? But the difference is, in case of your bond enthalpy, right? Last enthalpy, we take the overall compound and break all the possible bonds which are there in the compound, and you convert them into atoms. That's what we did. Correct, right? Here we are not going to speak in terms of the overall compound. We are going to speak in terms of one specific bond in a compound, right? I'll make it this thing, right? So for example, right? Say for example, I take the same example. I take CH3OH. Okay. Now, if I talk about bond dissociation enthalpy for CH3OH, right? Not, I mean, first of all, I should not speak like this. I told you should not speak in terms of the overall compound. Now, how can I speak? Is I can talk about bond dissociation enthalpy. Okay, just remember the letter D, D, E. Okay, so I can speak like this: bond dissociation enthalpy of OH bond in CH3OH. Are you able to understand? Right? We are going to speak about one specific bond in a compound. What is the energy required to break it? Okay, so that's the basic difference. In bond enthalpy, we talk about the overall compound, all the bonds getting broken. Right? Here in bond dissociation enthalpy, we talk about one specific type of a bond, say OH bond, CH bond, CC bond, something like that, right? In a particular compound. Understood? So we'll take the definition, people. Please take down the definition. So for bond dissociation enthalpy, it is the enthalpy change occurring. It is the enthalpy change occurring when one mole of a specific type of bond, when one mole of a specific type of bond in a compound, one mole of a specific type of a bond in a compound is broken. Okay, I'll repeat the entire statement again. So yeah, so it is the enthalpy change occurring when one mole of a specific type of a bond in a compound is broken. Very simple definition, right? So I take one mole of what do you mean by one mole? 6.023 into 23 number of these bonds, right? So that many bonds to be broken, specific type of bond, OH bond, CC bond, CH bond, right? All these to be broken, right? Whatever is the enthalpy is occurring is what is called as your bond dissociation
enthalpy. Okay, now how will I connect my bond enthalpy with my bond dissociation enthalpy is the question, right? Now, if you can think logically, right? So in bond enthalpy, or in, say in the case of enthalpies of atomization, right? Whatever the bonds are there in the compound, right? Whatever the type of bonds are there, all the bonds are broken. Is it not? Right? Now, actually, now if I speak in terms of specific bonds, that is in terms of bond dissociation enthalpies, right? So can I say sum of all the bond dissociation enthalpies? That is obviously you have to break individual bonds. When I talk about individual bonds, I go for bond dissociation enthalpy. So individual bonds breaking, I sum up all the energies. Obviously, if I sum up all the energies, I'll be getting your bond enthalpy. Right. If I give you an example, you'll understand better. I'll give you an example. Right. Okay. So how do I put it? Say I'll take a very, very simple example. Right. So let me take CH4. Okay. So let me tell you that bond enthalpy. Again, when I'm going to talk about the whole compound, I have to talk about bond enthalpy, not bond dissociation enthalpy. Okay. So this is equal to some X. No issues. And I know how to write my equation also, right? How do you write the equation? CH4 in gaseous phase is going to become carbon gas plus 4 hydrogen gas. And obviously the enthalpy change is X. No issues, right? Now, how do I connect it with my bond dissociation enthalpies, right? Now, please understand people, there are 4 CH bonds here, right? CH4, in CH4, how many CH bonds are there? I mean, there's only one type of bond. The only type of bond is CH bond. And how many such bonds are there? 4 CH bonds are there. Okay, so I can write it like this. The overall bond enthalpy of CH4, right? That is all the 4 bonds has to be broken, right? Now, how can I write it? I can write it like this. I can write as 4 into bond dissociation enthalpy of CH. Did you get my point? Hope you get my point, people. Right? So what I'm telling you is the overall bond enthalpy is okay. So what you're going to do for this to happen, for this reaction to happen, what you should do, you should make sure that all the bonds in the compound are broken. Right? Now, what are the types of bonds here? CH bond is the only type of bond. How many such bonds are there? 4 such CH bonds are there. Right? So if I want to connect my bond enthalpy with the bond enthalpy, so the overall bond enthalpy, I have to break all the bonds. And what are the bonds present? Only CH bond is present. So I take bond dissociation enthalpy of the CH bond, right? And obviously I have to multiply with the number of such bonds. 4 into bond dissociation enthalpy of CH. Very, very simple, right? Let me give you one more example and then I'll ask you for another example. Okay, any questions?
Sir, if we have 2 different type of bonds, what should we do, sir?
Coming to that. Yes, next example is that. Right? Oops. Guys, were you copying it?
Coffee, sir.
Okay, fine. So let me take an example like this. Say let me take C2H5OH. Okay. Now, first, obviously I know how to write the bond enthalpy equation. That we are not worried about, right? I'm directly going to connect my bond enthalpy with my bond dissociation enthalpy. Cool, right? Fine. Before that, we will just make sure that what are the types of bonds, right? And how many such bonds are there? First, we'll try to find out. You tell me, what are all the bonds present here?
Carbon hydrogen bond.
Okay, carbon hydrogen bond. How many such bonds are there? Okay, let me write. If I write it like this, maybe you'll not understand. CH3, CH2, OH. This is the overall. Now you tell me. So CH bond is there. How many CH bonds are there?
Totally, sir, we have to say.
Totally. In this compound,
5, sir.
5, right? So obviously you can see CH3, 3 bonds, CH2, 2 CH bonds. Totally 5 CH bonds. Okay. What else? What other bonds are there?
OH bond. One OH.
Okay. OH bond. Obviously, only one OH bond is there. So one. Okay. What else? What other bonds are there? Only one more type is remaining. What is it?
Carbon, oxygen.
Exactly, right. So you have a carbon-oxygen bond also. Carbon-oxygen bond, there is one bond. Wonderful. Right. So this, if you're done, obviously the other things are going to be very easy. Right. So if I want to write the bond enthalpy of C2H5OH, and if I want to connect it to the bond dissociation enthalpies, it's very simple, right? It's equal to, now first I'll take my CH bonds. Obviously it has to be broken. Now there are 5 such bonds. So 5 into bond dissociation enthalpy of CH bond. Done. I have to sum up all the things. That's it. Plus, how many orders is there? One OH bond is there. So bond dissociation enthalpy of OH bond. What is left out? CO bond. So plus bond dissociation enthalpy of CO bond. So the overall bond enthalpy, you have to make sure that all the possible bonds are broken. And I have made sure that all the possible bonds are broken so that this compound will get converted into its corresponding atoms in gaseous phase. Yes, understood? Rohan, is that now it's
Yes, sir. I understood now, sir.
Right? Okay. Let me give you one more example, but this time you are going to answer it. I'm going to ask someone. Please be ready. Right? So if you want to copy this one, copy this one. Give you 30 seconds.
Done, sir.
Yeah. Okay. So let me take C6H5NH2. Basically, this is my only. Okay, and I don't have to know the compound anyways. So yeah, this compound is given, right? So bond enthalpy of C6H5N. Okay, now actually this will be little difficult for you to understand what type of bonds are present. Let me take a little easier example. Okay, fine. Let me take CH3, CH2, NH2. Okay, this is my amine. Okay, don't worry. These are all organic compounds that will be coming very soon for you, right? So I'm asking bond enthalpy of CH3, whatever it is, C2H5NH2. This is what is C2H5NH2, right? So will be equal to in terms of bond dissociation enthalpy. Okay, now whom should I ask? Maybe Rahul. Can you help me out? Rahul, are you there?
Yes, sir. Yes, sir. Yes, sir.
Can you tell me, Kanna? First, tell me. You can directly do it if you want, but now since you're only starting, we'll just start with what are the types of bonds and how many such bonds are there. Can you first tell me what first type of bond? What is it?
CH bond into 5.
Okay, very good. So I have 5 CH bonds. Good. Then
NH bond into 2.
okay, very good. So I have 2 NH bonds. Then
That's it, sir.
that's it. Don't you see another bond?
Sir, are we supposed to include carbon nitrogen bonds, sir?
Actually, we forgot one thing last time. So when I
But
had
carbon bond also.
exactly, when I had CH3 CH2OH, we talked about CH bond, we talked about OH bond, we talked about CO bond, but what about CC bond? It's there, right?
Yes, sir.
Correct. So we missed this last time, right? So that also has to be included, people. Go to the previous example and write plus BDE of CC bond also. Okay, right? So again, this will also come here. So we did a mistake last time. Please correct it. Please include this CC bond also. Okay, right? Okay, fine. Now you can continue, Rahul. Tell me. So CH bond is over, NH bond is over. Then
CN bond.
good. How many? Obviously only
One.
one. Okay, then
CC bond 1.
okay, cool. So yeah, so these are all the different types of bonds present, right? Okay, now we'll go for the bond dissociation enthalpies. Quickly go for it. BDE of
BDE of CH into 5
okay into 5 plus
plus
then
BDE of NH into 2
good, then
plus BDE of CN into 1
good
plus BDE of CC into 1.
good. Very good, Rahul. Right. So obviously, right, I think everybody has understood whatever it is, right? Yeah. So yeah, please, you have see, you just have to look at whatever the type of bonds are possible, and if you miss even one type of bond, the entire problem might go wrong. Okay, see, even though I am so much, I have been teaching this, but see, even I missed my CC bond. So obviously, you are bound to miss. Okay, so be very careful when you're doing the problems. Okay, fine. So that's about your bond enthalpies and bond dissociation enthalpies. Is that understood? Right? Okay. Now, yeah.
So if there are double bonds or triple bonds in the equation, what should we do, sir?
Okay, we'll take another example for that also. If you're copying this, copy this. Okay. Okay. So let me take CH2 double bond CH, CH2. Let me take. Okay, fine. Now, very simple. So bond enthalpy of this compound, whatever the compound is, right? So fine. So now you see there is a double bond between a carbon, there is a single bond between a carbon, and they have to be treated separately. Definitely. Now you can understand, right? When I have a C double bond C and a C single bond C, for C double bond C, I have to supply more energy for breaking it because it's a stronger bond, right? But for C, the C single bond C, lesser energy is only required. So obviously you have to treat them as two separate types of bonds. Okay. So now how will I write it? Is bond dissociation enthalpy. Now I have one C double bond C, right? So bond is an enthalpy of C double bond C plus how many CH bonds are there? Only one single bond is there. So one double bond, one single bond. Bond dissociation enthalpy of one CC single bond, done. And next whatever is remaining, and BDE of CH bond. Now you have two CH bond, one CH bond makes it 3 plus 1, 3 plus 2, 5. So CH bond into 5 is 2, 3, 5. 5 plus, also plus bond dissociation enthalpy of, what else is there? OH bond is there, plus bond dissociation enthalpy of, what is there? CO bond is there. That's it. This is how you write it.
Understood now, sir.
Right? So whatever, so if you have a single bond, double bond, triple bond, treat them separately. That's it.
Yes, sir. Understood.
Okay, cool. It's a nice question actually. Okay, done. So now, how we connected your overall enthalpy, right? We connected the overall enthalpy of a reaction to enthalpies of formation and enthalpies of combustion, right? Like that, I'll be able to connect my overall enthalpy of reaction to the bond enthalpies also. Very simple. And again, just like how we did there, now here also we can do. Okay, so how are we going to do that? We'll see. Right. So again, take this down, people. Delta HR, that is the overall enthalpy of a reaction, right, is equal to total bond enthalpy. See, I'm talking not about bond dissociation enthalpy. I'm talking about bond enthalpy because we're talking about the overall compounds, right? So bond enthalpy of reactants minus total bond enthalpy of products. It's just like enthalpies of combustion. In enthalpy of combustion, I speak reactants minus products. Here also it is going to be reactants minus products. Understood? Right? So this is how we connect enthalpies of reaction with your bond enthalpies. Very, very simple. Okay. Yeah. Now, other than this, I have so many other types of enthalpies, like say enthalpies of vaporization. Now, if I go for the physical processes, say sublimation, vaporization, what else? Fusion, that is melting, right? So it's very simple. So, for example, if I say that enthalpy of fusion of water is some x, right? And if I say FUS, it's fusion. Fusion means melting. Okay, so if I say enthalpy of water, enthalpy of fusion of water is some x, how will I write the equation? Can you guess how will I write the equation for this? It need not be right. We can give you a guesses. So in melting, what phase changes to what phase?
Solid state changes to liquid state, sir.
Good. That's it. Now you can write the equation. Just a wild guess. Now that you told me that in fusion solid phase gets converted to liquid phase and both are water only, there is no chemical composition changes. So how will I write the equation? H plus O. No pronoun.
H2 solid gives H2 liquid plus.
Good. That's it. Yes, and obviously, yeah, the enthalpy change would be X. Yes, very good, Shruti. Shruti only, right?
Bhavdani, sir.
Oh, Bhavadharan. Yes, Bhavadharan. Yes, good. Correct. Right. So obviously, I'll write it as H2O. Since it's fusion in solid phase gives H2O in liquid phase, and enthalpy for this reaction is X. Very, very simple. Right. So let me ask you one more thing. Maybe enthalpy of sublimation of sodium is some Y. How will you write the equation? SUB is sublimation. Okay, now tell me. In sublimation, we know what happens, right?
Solid
changes to
sodium
gases.
changes to gaseous sodium.
Correct. Right. So how will you write the equation?
Na solid on heating is Na gas.
No, you don't have to write anything. Heating and all, you don't have to write. You can just write sodium solid gives sodium gas. The enthalpy for this reaction is
Y.
Very simple. Okay, right. So like this also they might give you, like the data can be given in terms of this physical processes also. It's understood. And I forgot to tell you one main thing. I forgot to tell you this. So whenever you see people, whenever you see enthalpy of a reaction or whatever it is, enthalpy is positive, right? That means it is going to be an endothermic reaction. Okay. Now it's just like heat, no? How do we have sign conventions? In sign conventions, what we do for heat absorbed by the system or heat given to the system is positive, and heat lost to the surroundings is going to be negative, right? So I know in an endothermic chemical reaction, I supply heat. So that means heat is given to the system. So obviously, you will find that it is going to be a positive value. Okay. And whenever you see enthalpy of something is going to be negative, and obviously it is going to be an exothermic reaction. Is it okay? Right. So these are the informations you need to know. Right. Do you have your chemistry books open with you, your NCERT textbooks? If not, anyone can please open it and tell me what are all the other enthalpies which you have. Do you have enthalpy of neutralization? There are so many other enthalpies, but I don't know what's there in your syllabus. Can someone please quickly check and tell me?
Sir?
So we have enthalpy change during phase transformations.
That is okay. That is in sublimation, vaporization, and all fusion and all these. Okay. Other
Then
than
we have
that,
standard enthalpy of reactions. So
okay. So that's very simple, people. Standard enthalpy, they will put like a delta H dot. So when they put this, it is called standard enthalpy, right? So standard enthalpy means obviously only that the conditions are going to differ, right? So when I say standard, temperature should be 25 degrees Celsius and pressure should be 1 atm. That is, have to do with the room temperature and normal conditions. That's it. So when I say standard enthalpy, for anything, standard enthalpy of formation, standard enthalpy of combustion, whatever it is, the definitions we told are exactly same. But the only difference is when I say standard, temperature is room temperature 25 degrees Celsius and pressure should be 1 atm for that process. That's it. That is what is standard enthalpy. Okay, I think I made sense. What else is there?
We have lattice enthalpy also, sir.
Okay, lattice enthalpy. Okay, other than that,
then we did one thing, enthalpy of formation.
enthalpy of formation completed. Then
Enthalpy of solution. Enthalpy of
enthalpy of
dilution.
solution.
Yes, sir.
Okay,
Dilution and
solution and
solution.
dilution. Okay, then did we have bond enthalpy or enthalpy of atomization?
Yes, sir. Both are there, sir.
Both are there. Okay. So the only two things are remaining is enthalpy of solution and lattice enthalpy. Is that cool? Anything else?
Yes, sir.
Okay, fine. So I can teach you enthalpy of solution now. Then we can maybe next class I'll teach you lattice enthalpy. Okay, fine. So and we have to do problems obviously. So people, next class I'll be teaching you lattice enthalpy, right? And we'll be completing enthalpy of solution now, right? And I'll teach you lattice enthalpy and we'll do some problems, right? So with that, the second part of thermodynamics is over, right? The third part is very small. So I told you we'll be learning about engines, entropies, why is it that what to say, when I keep ice at room temperature it melts, right? So there are so many spontaneities and stuff will come into the picture. That's very interesting, right? So anyways, we'll go through this.
So we have even enthalpy of dilution, sir.
That is what enthalpy of solution, enthalpy of dilution, all the same. Do you have separate? No, right?
Separately given.
Separate, sir.
Okay, fine. We'll see. Okay, so now this thing is enthalpy of solution, right? So this enthalpy of solution doesn't have a proper definition, right? But no, okay, why is it like that if you ask me? Because it's a sum of two other enthalpies. Okay, my enthalpy of solution is basically going to be the sum of two other enthalpies. Okay, so what are the two other enthalpies? So if I write delta H solution is equal to two other enthalpies. One is your lattice enthalpy. So for this, obviously, I have to teach you what is lattice enthalpy then. Okay, another one is going to be my hydration enthalpy. Okay, so enthalpy of solution, right, is going to be the sum of your lattice enthalpy plus the hydration enthalpy. Okay, fine. So what do you mean by lattice? First of all, before saying any of this, we have to understand how a solution is formed. If you understand that, then this all makes sense. Okay, now let me take a very simple example. Okay, So I have sodium chloride crystals with me, okay, and I'm going to dissolve it in water, right? Okay. So obviously you can understand, people. NaCl will have this NaCl, obviously Na plus Cl minus. Obviously, I can say that NaCl interactions are there. Or let me take you a little more common example. Not common example. I have a solute. I have a solvent. No issues, right? So before you form the solution, right? Before the solution is getting formed, you have two types of interaction. What are the two types of interaction? You have solute interaction. There is going to be interaction between the solute only, right? And in the solvent, you have solvent interaction. No, sure, fine, solvent, right? Solute interactions and solvent interaction. Okay, so now when you make the solution, when the solution is formed now, right, there you will have all of these, obviously, because all of them are a little close together. You will have solute, you will have solvent. But other than this, I will have this also, that is solute-solvent interactions will be there. Is it not? Right? Okay. Now what you have to understand is, people, right? So you are going to break some of the solute-solute interactions, right? And you are going to break some of the solvent-solvent interaction, and you are going to make some solute-solvent interaction. Is it not? Okay. Now, if at all you want to have a completely dissolved solution, okay, if at all you want complete dissolution, when I say dissolution, completely getting dissolved. Okay, so if at all you want complete dissolution, now please talk in terms of energy here. When I speak in terms of energies, so obviously for you to break this kind of interaction, energy is supplied. Okay, and obviously if at all you need to have this, when I told you, whenever a bond is broken, you need to supply energy. Whenever a bond is formed, energy is released. Is it not? So you are breaking some bonds, so obviously energy is supplied, and for this obviously energy will be released. Okay, now these two energies are what we are speaking about here. Okay, so lattice enthalpy talks about breaking. That is, when I have the NaCl crystal, right? So those NaCl crystals should be broken. Mummy, sorry guys. Okay, so yeah, so what I was telling, so I have NaCl crystals with me, right? So those NaCl crystals should be broken to Na plus and Cl minus first, right? So that is my lattice enthalpy, right? And obviously after Na plus and Cl minus is formed, that is going to be in water, right? We know what is going to happen. We know we are going to have hydration. I told you what hydration is, right? What do you mean by hydration, people? What do you mean by hydration? We spoke about this in chemical bonding, if you can remember. Okay. Anyways, if you don't remember, we'll talk about it again.
What did you ask?
I asked, what do you mean by hydration or solvation? I mean, if it's any solvent for that matter.
Hydration means, yeah, any substance that contains water reacts with the water.
You cannot say react. Anyways, no issues, people. Right? We'll talk about it again. Don't worry. I'll speak about hydration enthalpy separately. Okay. So, anyways, what you have to understand is you are going to break something. You are going to make something. Right? So that breaking is talking is in terms of the lattice enthalpy, and this hydration is going to be in terms of your energy supplied, or you would say it is for making the bonds. It is for making the bonds. Okay, so lattice enthalpy is for breaking solute solvent interaction, right? And you form the solute solvent interaction, so that will be taken care by your hydration enthalpy, or in general I can say solvation enthalpy. Now when I say hydration, that means solvent is always water, but when I say solvation enthalpy, that means the solvent can be anything. But yeah, we generally speak only in terms of your hydration. Okay, so we'll speak in detail about this next class, and I will just see what you mean by enthalpy of dilution. Maybe when I add more and more water, whatever happens, the energy released is what is they're asking. Maybe. Anyways, I'll look into it. Okay. So this is the enthalpy of solution. We'll speak about it more and we'll do some problems next class. People. And I'll make sure my laptop is ready. I don't know what problems I have. And maybe I know. Let's see how it goes. Okay. Any questions from here or from whatever we saw today?
No, sir.
No, sir.
Okay. Cool. Still people, you can go take some rest and you can go out on your. I wanted to ask you, in your school, what chapter are they teaching?
They are doing volume 2, sir. They have not done gaseous state.
Volume 2. They went to this thing, organic.
Yes, sir. Now they're teaching organic currently. But they didn't do equilibrium, thermodynamics, or
Oh,
state
so they
cycles,
finished
sir.
gaseous state and they went for
No, sir. No, sir. They didn't finish gaseous state.
gaseous also they didn't complete.
They did chemical bonding and then they started volume 2.
Oh, maybe they didn't want to start physical. Maybe they finished inorganic and then they went for organic. But still, okay, don't worry. So I have after this I have equilibrium. That's your last physical chemistry chapter, and then we'll go for organic. That's it, and the syllabus will be over.
Sir, doubt,
Okay.
sir. You'll be teaching even S block, P block classification.
Oh, yeah. S block and P block. I'll tell you how are you going to do it. I'm not going to teach you as such, right? So maybe for S and P block, there are like, I think some 9-10 people. So maybe I will divide you into 5 groups, 2 people each. Okay. So we might have it for 3 days or 3 classes maybe. So I will ask you to study some portions and come, right? And there'll be a quiz. That's how it's going to be. Because that chapter is very boring. Okay, like this full theory basically. If I teach you, you will sleep. Even it's the most boring chapter to teach also. So how I will plan is basically you will be studying. I'll tell you a portion to study and come. You will study that and come, and we'll be having a quiz from that particular portion. And I'll tell you the details. Like it's going to come at the last. Anyways, I'm just giving you a heads up now only. Okay, so I'll be dividing it into groups. So you will get all the information possible from your books or whatever the extra materials you have, and you'll come back here, and then I'll be conducting a quiz for you, and like groups, obviously. Is that okay?
The same thing for even hydrogen chapter, sir. Then.
Hydrogen is not there, no? It is taken out, right? For your this thing.
It's taken out, sir.
Yeah, I mean this year because of the pandemic, they wanted to reduce the syllabus. I think hydrogen is not there. Hydrogen, environmental chemistry, all these chapters are not there.
Okay, sir.
Right? Okay. Cool. Thank you. Thank you so much. We'll meet again.
Thank you,
Thank
sir.
you, sir.
You.